Hi everyone. Graphing inequalities, graphing linear inequalities to be specific, is the task on this side of the paper, and I want to do just a couple of them and let you kind of finish up. I promised we won't do 8 and 9, but let's look at a couple of these. Now these first two only have a y or an x. It does not have both x and y. That is an indication that you're either going to be horizontal or vertical with your lines. And this one is y is less than -3. Well, if I'm on the y-axis, there is -3 on the y-axis. It's less than or equal to. And I know the y-axis is the vertical axis, but when you have y equals 3, you have a horizontal line because the y-coordinates are, this is 1, 3, 2, 3, 3, 3, 4, 3, 0, 3, -1, 3, -2, 3, -3, 3, -4, 3. The y-coordinate every time I said was -3. Now y equals -3 is part of the solution. So that line is part of the solution. Values that have y-coordinates less than -3 are below the line. So we're going to shade below the line. Okay, if that is a vertical line, this boundary line will probably not be horizontal like this one was. This one will be, and I'll leave the rest for you. Another problem I want to do is I'd like to take a look at, let's look at number 4. Now, the boundary line is y equals -3x plus 5, but the boundary line is not a part of the solution. So what are we going to do? We're going to plot that line, but not with a solid line that is very inclusive. We're going to use a dotted line. 1, 2, 3, 4, 5. If you remember, this is the b value. This is the y-intercept. I'm going to put -3 over 1 because I'm going to go down 3 and over 1, down 3 again and over 1, because that is the slope. So I have a point, I got the slope. I'm going to draw a dotted line so as not to include that line as part of the solution. Now, the values, so for if x is 0, y is 5. We got that point plotted. Well, y is less than 5 according to our inequality, so it's down here somewhere, like 4 or 3 or to anything down here. When x is 1, y is -3 plus 5 is 2. Well, but y needs to be, according to our inequality, less than that. So we're shading below, and I think if you try that anywhere on this grid, you're going to be below that line. So we will shade that side of the line. And then the last one I want to try is number 7. And the reason I want to try that one, that is x minus 3y is less than or equal to 6, because it is kind of in a standard form. X minus 3y equals 6. Now I could solve for y and get it and use the slope and the y-intercept and make the graph, but I would also like for you to consider doing the intercept method. If x is 0, I'm going to cover up the x because it's 0, it's gone. -3y equals 6 if x is 0. And if I divide both sides by -3, I get y equal to -2. Now if y is 0, okay, that is going away. X is going to have to be 6. 6 minus 3 times 0 is 6. So what I have is a y-intercept of -2, an x-intercept of 6, 1, 2, 3, 4, 5, 6, according to the table, and I'm just going to draw a solid line this time because the line is part of the solution. Now, the points on this side of the line might be the solutions, or the points on this side of the line might be the solution. I'm not quite sure. So one of the methods we can do is look for a test point. I'm going to use 0, 0. Now, I'm going to plug into x minus 3y is less than or equal to 6, 0 for x and 0 for y. And is 0 less than or equal to 6? Yes. 0 is less than 6. With that being the case, since that point is a solution, every point on that side of the line is a solution. If I were to try a point on this side, let's look for something easy. Right here. That point is negative 3, 3. Oops. It's positive 3, negative 3. Got those two turned around. Okay, plug it in. X is 3 minus 3 times negative 3. Is that less than or equal to 6? 3, that's 3 plus 9 basically. That's 12. 12 less than or equal to 6? No. This point, as well as every other point on this side of the line, would not be a solution. Okay, you might want to consider trying the intercept method on number 3. You could possibly try that. This is slope-intercept. I would use slope-intercept there. You could change that either to intercept method like this or slope-intercept if you add 1 to both sides, and that might be the easiest way. I'll leave that up to you. But I do want to get you started on this. A school system is buying new computers. They will buy desktop computers costing $1,000 per unit and notebook computers costing $1,200 per unit. The total cost of the computers cannot exceed $80,000. All right, let's let D be the number of desktops that you can buy. So 1,000 times D is how much you spend on desktops. Let's let N be the number of notebook computers. 1,200 times N is how much you spend for that total. The total cost cannot exceed, can't be bigger. Let's not make it bigger than 80,000. Let's make it less than or equal to 80,000. And I would definitely use N and D, the intercept method, when I'm graphing this. And I'll leave the rest for you. Have fun with this and talk to you tomorrow.